So the title of it, you see a lot of familiar words. You see unit rates, you see fractions. We've done both so far this year. We've done unit rates, we've done fractions. I highlighted the word complex fraction because you may or may not have heard of what a complex fraction is. And I know what some of you are thinking. Great, I just kind of learned what fractions mean, and now you're going to go and make them double hard on me, complex fractions. So let's do 2 quick review skills before we move on. Skills review of just regular dividing, skills review of unit rates, and then we're going to combine a couple things for the bottom. So hopefully you remember back to 2, 6, 2, 7 when we multiplied and divided fractions. The first thing we learned is that we didn't divide fractions. We changed them into multiplication. And then I know every year when I teach this, I hear somebody say, keep, change, flip, and then I always say, you are not allowed to say that this year. Do not let your teacher tell you that, because that just is one of those things that we don't want to memorize it. We want to use the correct math terms. Yes. So keep is okay. So let's talk about the keep. The keep means go ahead and keep that 1/2. Keep that first number every single time. Okay? The change, well, I kind of want you to be more specific and use some math terms. What are you changing? You're changing division to multiplication, and that means you're taking the inverse operation. So you're changing your division to multiplication, and then you're not flipping the second number. There is a more, better math term than that for flipping, and it's reciprocal. And the reciprocal of 1/4 is 4/1. And now that it's a multiplication problem, you know what to do from there. Okay? So you look to see if you can cross cancel. That is your best option. Cross cancel a 2, and a 2 goes in there. So your final answer is equal to 2. Kind of a piece of cake, right? We've done this. So let's just do another quick review one. Go ahead and try to rewrite that one on your own, so I don't have to rewrite it for you. Just kind of see. 2, please. So don't divide by 2/5, multiply by 5/2. Look to see if you can cross cancel, and you can't. The GCF of both the diagonals is 1, which means you're good. So you can't cross cancel, you just multiply 1 times 5 and 3 times 2. Done. Then 3 and 4 kind of get into some trickier ones. 1/4 divided by divided by 2. You know when you have a whole number like that, you have to make it into a fraction. So 2 just becomes 2/1. Keep, inverse, reciprocal. This is kind of pretty easy. Your answer is just 1/8, okay? For number 4, I want you to add a 1 for me in front of the 7/8 because I want you to have a little bit of practice with some mixed numbers. So make that 7/8 please into 1 7/8. I will tell you from years and years of experience with dividing with mixed numbers, these are the problems that most kids get wrong, okay? Because they forget to do something. So first of all, 4 becomes 4/1, okay? Here's what I want you to do. Do you know those little cartoon, like, conversation bubbles? Like, where they go like this, boop, 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 and then they're, like, thinking of something? So this is what I tried to get you to do before. We're going to do a little cartoon conversation bubble because in that little bubble, I want you to write what 1 7/8 really is as an improper fraction. The mistake that most kids make every year when they do this is what they do. I'm going to get a pencil because I need to erase it. They'll keep this, they'll change this, and then they'll say 15/8. Do a little error analysis on that. What did I just do wrong? I didn't flip it. I didn't take the reciprocal. But people are thinking, oh, I changed something. Well, you didn't change what you're supposed to. So I'm wanting from you a little bubble up here, and I want you to kind of know that, oh, okay, it's like it's one day it's dreaming of being 15/8. Well, it's 15/8. It's silly, but I know. So now I've all see 15/8, and now you go, oh, so that I make 8/15. Yes. So change that to 8/15, okay? So now you look at, you try to cross cancel 4 and 15, but you can't. You have no choice. You just have to do 4 times 8 is 32. 1 times 15 is 15. Then we have to put it back into mixed number, which is what, Desmond? Yep, 2 and 2/15. Awesome. So how we did that, he said 15 can fit into 32 twice, which gets me to 30. Count up to 32. You have 2 left over, and the denominator never changes. Okay? That was a quick dividing fractions review. Good, right? Does this kind of ring a bell? All right. Well, concept review of unit rates is like going to be a piece of cake because we just did unit rate test yesterday, right? So what is a unit rate? The definition, the true definition of a unit rate is a rate, meaning a fraction, with, this is a shortcut for with, a denominator, that's, I'm going to abbreviate, denominator of 1, right? Unit rate is a rate with a denominator of 1. The easy way for you to say that is I say this, how much for 1? Okay? How much for 1? That's like an easy question to answer. And the answer to that gives you your unit rate. How much for 1? 12 pairs of jeans cost $300. How much did 1 pair cost, right? Okay. Now, this problem is going to bring up a really good point. So, when I read that problem, it says Mike walked 5 blocks and it took him 15 minutes to walk that far. All the problems we've done up to today, the question would be, how many blocks did he walk in 1 minute, right? And what I'm about to tell you is going to make you think I've been lying to you. And I promise I haven't. But remember what I said, that the unit rate for time always goes in the bottom? And up until now, it has. So this is where we're kind of doing something new. I want you to look through that paragraph until you see the word 1. You see it? It's in the 3rd line. What word is after the word 1? Block. I want you to put a box around that. 1 block. So, do you remember those cards that you did on the like the stations activity where we did the game? It said write the proportion 2 ways. Minutes per hour or hours per minute. We're doing it the other way now. So I don't want to know how many blocks he did in 1 minute. I want to know how many minutes it took him to do 1 block. Do you understand? So this little box right here is going to be the deciding factor on whether you get this right or not. So I want you to go down here. I want you to write your 2 fractions. And in my answer, I want to know how much it is for 1 block. And I know what you're thinking, but minutes, you said time always goes in the denominator. Yeah, it normally does unless they ask you to put it the other way. And today, they're asking you to put it the other way. So did everybody listen? Is everybody on high alert right now? Because if you just missed what I said, you're going to do everything backwards today. The goal today is figure out what the 1 is, put it there, and then the rest is easy. Because and here's the other thing I want you to do. Words, 2 words. Figure out what you're doing. You're doing blocks and minutes. Remember how I kept saying, guys, got to show your words. Well, those are the 2 words we're going to use. And I already know blocks goes here, which means minutes must go in the numerator. That's kind of weird. Yep. That's how we're doing it today. So watch, now I fill it in. 5 is a blocks number. 15 is a minutes number. And then I do 15 divided by 5 and get 3. 3 what? Minutes. Let's think about that. Basically what that means is every block that he walks, another 3 minutes just went by. So if this was my number of minutes, this was the number of blocks, assuming you were walking the same pace. So let's say 3 minutes went by, I just won a block. Another 3 minutes went by, now I'm on my second block. Do you see? Watch what keeps happening. As 3 more minutes goes by, I keep covering more blocks. When I'm at 12, I would be at 4 blocks. Hey, look, this is how I know I'm right. Because they told me this information in the problem. That's how you know it's 3 for 1. All right. So are you good on that? Okay, because that was meant to just kind of be a review. Trent. Yep, and that's exactly right. He said, I just did how many times is 5 going to 15? And that's right. But remember how picky I am about unit rate. You got to show those words and those fractions. Okay, let's scooch this up a little bit. Let's find out what a complex fraction is. A complex fraction is kind of like a double whammy. So if you already had problems with fractions to begin with, we're just going to make it a little more complicated. And then I'm going to kind of really show you how to work with it. And you're going to be like, oh, duh, that's it. Okay? So the definition of a complex fraction is a fraction with a fraction in it. You're like, what? Isn't it a fraction? I'll show you. A fraction with a fraction in it. And by it, mean it could be in the numerator, it could be in the denominator, or if they really want to mess with you, they can put it in both. So a fraction with a fraction in the denominator, numerator, or both. Okay? And after you get that written, I want you to look at the examples of these complex fractions below. A denominator, numerator, or both. And so I want you to kind of darken in the main fraction bar. So if you have a marker or whatever, you just darken it with your pencil. If that's the main fraction bar, 1/2 is my numerator. How messed up is that? It's not too bad. So this is my main fraction bar. And this time I have a fraction in the denominator. I want you to, again, add that 1 in front, please. So my main fraction bar is here, and I got a fraction in both. These are complex fractions. It's a fraction built into a fraction. Fraction within a fraction. Got it?
Is there a fraction within a fraction within a fraction?
So what Michael's is saying is, could you do this as your denominator, and I could do the same thing up top? Yeah, they won't do that to you probably. I mean, you could figure it out, right? Okay, so I'm going to show you how to figure out working with complex fractions, and guess what? You already know. You just don't know that you know. Simplify these by dividing. Ready for this? If I were to ask you to read that to me, how would you read that? You wouldn't say 1/2 fourths, right? What does a fraction bar mean? Oh, a fraction bar just means divide. So you mean this just is said as 1/2 divided by 4? Yep. Write an arrow. This just means 1/2 divided by 4. Ta-da! I'm going to scroll. I say scroll back up like everything is electronic. I'm going to have you look back up here. When I did those 4 review problems, how many of you were following me? It was fine, right? Now this is a division problem, and that's it. So if that's how I rewrite this, how would I rewrite that? 6
Divided by 3/4.
Good. 6 divided by 3/4. That is literally it. So I'm turning these complex fractions into non-complex fractions, basically. We dealt with this already. So go ahead and rewrite that one. Rewrite this complex fraction as the good old regular one, okay? Something we already know how to do.
I forgot.
Okay. So now you know we don't divide fractions, we multiply by the reciprocal. We won't finish these out completely, but let's at least turn them into multiplication problems. This problem is really going to be what?
1/2 times 1/4.
Okay, this one's easy to do. That's our 1/8, right? This one's going to become what?
6/1 times 4 thirds.
Yep. And you could either make it 12 thirds, which is 4, or you could, 12 thirds, not 12 thirds, I'm thinking of what the answer is, 24 thirds, which is 8, or you could cross cancel, and the answer is 8. Okay, 4 times 2, and 8 over 1 is the same as 8. Okay, soon as you see a mixed number in the second spot of a division problem, you do a little thought bubble. And that 1 7/8, we've seen it a couple minutes ago. It's 1 times 8 plus 7, right? It's 15/8. So now that I'm seeing that, it's a little more clearer to me that I really want to multiply not by 15/8, by 8/15. Okay? And this answer is just going to give me 8/45. Okay. All right, so that's the deal with complex fractions. We'll do 2 review problems together. We'll do 2 of these together, and then you're going to do 3 on your own, and then that's going to be it for complex fractions. So turn your notebook to the yellow sheet, please. Here's what's so awesome about this. I love this, the way that it's set up, because it tells you 1, 2, 3. First do this, then do this, then do this. So stay with me for 2 more problems, and then we're good. All right? If Jenny took 2 hours to knit a third of a scarf, how many hours will it take her to make a whole scarf? And here's what was funny. When I gave these notes second hour, I had like 2 or 3 people's hands shoot up right away because they knew the answer right away. And then I had somebody look at them and they were like, how did you just do all of that in your head? Because they were thinking that they were doing like all this stuff. I knew what they really did. Let me show you what they did, okay? I said, well, let's take this rectangle. A rectangle in math can really stand for whatever you want it to stand for. And right now, it's going to represent a scarf. Okay? Here's my scarf. It's one whole scarf. I'm going to separate that scarf into thirds, which means I'm only going to draw 2 lines. How long, and this, by the way, is all I got knitted or sewn, okay? Yep. Xander, do you have questions?
Yeah, I think I might know.
How much?
It would take 6 hours.
Yes, it would. Does anybody else know right away that it was 6? Here's how. I'm going to visually show you with a model what you were able to do in your head. So, does everybody agree that that's 1/3 of a scarf? Okay? That's a third, and that's another third. And 1/3 plus 1/3 plus 1/3 equals 1 whole. And how long did it take them? 2 hours. So, here's the most important part about this. Assuming that they were knitting at the same rate the whole time, because they can't slow down or speed up. They have to stay at that same rate. It took them another 2 hours to do the next third. And another 2 hours to do the next third. So by the time the whole scarf was knitted, they were knitting for how many hours? 6 hours for, oh, look how beautiful this works out. 1 scarf, right? So, I want you to notice something. Remember what I said? Look for the word. Every one of these problems is going to start out with you looking for the word 1. Do you see it? There it is. Box it. Box it out. 1 scarf. Oh, that must mean I don't want to know how many scarves I could knit in 1 hour. I want to know how many hours did it take me to knit 1 scarf. Do you see what I'm saying? Watch my hands. Look up here. I don't want to know how many scarves can I knit in 1 hour. I want to know how many hours does it take me to knit 1 scarf. Do you see I just kind of flip-flop those fractions around? So, set up the ratio. Awesome. Let's set it up. 1 goes where? The scarves go in the bottom. Right? So take that and know that you're going to do 1 scarf. That's how I know the scarf goes in the bottom. And my hours is going to go up here. Oh, what else did I want you to do? figure out what two variables you are comparing, because that's what a ratio is. It's not scarves per hour, it's hours per scarf. So let's say I want to make a scarf for my friend for her birthday. I need to know how many hours I need to set aside for one scarf. Okay, so the hours is 2. The scarf's number is 1/3. So now let's simplify that. So in the simplify spot, actually, you know what? I'm sorry. If you wrote in pencil, I want you to erase this. If you didn't, just kind of scribble it out. Okay? Yeah, erase it if you did. Because here's what I really want you to put. It's white out. So simplify means show your work here. So what this is going to be is, what does this look like as a fraction? Oh, it looks like 2 divided by 1/3 is what it looks like, right? So 2 divided by 1/3. Oh, that's driving me nuts. I just want to get that one little bit there, but I can't. Really looks like what? 2/1 times 3/1. Awesome. It's just 2 times 3, right? 6/1 is the same as 6. Okay. I set up the ratio. Step 1, check. I turned it into a division problem and simplified it. Step 2, done. I am seriously so close to having a perfect answer. Here's what I want you to do. Remember how nuts I was yesterday about label it with appropriate units? That's where you can kind of draw a little arrow, because we're going to get help from step 1 here. That's where I'm going to say, okay, hours and scarf. I hit that in the wrong spot. I know that's a 1, because that's the definition of a unit rate, right? A ratio with the denominator 1. And then I figured that out, and that was 6. So, good? Does that make sense? Let's do another one. Scroll on up. So, read it. Mike can read 1/4 of the newspaper in 1/3 of an hour. That just sounds confusing. Not if you step it out. 1, 2, 3. How long will it take him to read the whole paper? Well, I don't see the word 1, but I see a word that kind of could mean 1. What is it?
An hour.
No. Whole. 1 whole, right? So let's box that out. These are what you're watching me do is exactly what you're going to do when I give you your 3 practice problems. Box it out. Set up a ratio here and a ratio here. Whole paper. Whole means 1. And if 1 is what I want, where does the word paper go? Actually, let's figure out what we're doing. Paper and hour. The most important part of this whole problem is what word to put where. Where does it go, Xander?
Newspaper goes on the bottom and an hour goes on the
Yep. 1 paper. So the word paper goes here. And the hour goes up top. Now I'm going to take the numbers from my problem and create my ratio. So 1/4 is a newspaper number. So where does that go? See why the words are so important?
Yeah.
Here, let me tell you why it's so important. Because you want to know, and an hour is a number at 1/3. Because people who don't listen in class think that the number goes whatever's first in the problem must go on top of the fraction. Is that true? No. Do you agree it just took a little bit of listening for you to go, oh, this is easy? Okay? So now, let's simplify it. This fraction bar means divide. 1/3 divided by 1/4. Yeah.
Shouldn't we put the 1 in front of the 1/4? Since we're doing 2 divisions. I thought we did that.
Oh, no. That was just me adding it in because I wanted to change the problem. You're talking about for the 7/8? Yeah. Okay, we don't do divide. We multiply by the reciprocal. And 4 times 1 is 4. 3 times 1 is 3. And that's 1 in 1/3 of an hour. So the 1 in 1/3 of an hour goes here. Let me just draw you a little picture. If you liked the picture last time, There's the newspaper. To separate something into fourths, you split it in half, and then half again. Because half of a half is a fourth, right? This equals one whole newspaper. I read a fourth of this newspaper. How long did it take me to read a fourth of that newspaper? A third of an hour. So when I read the next fourth of the newspaper, it took me another third of an hour. And keep going. Now I'm at 3/4. And then finally the fourth meant I read the whole. And each time I read a fourth of this paper, by the time I read the whole paper, it took me 1 + 1 + 1 + 1, right? Do you see it? So here's the deal. Somebody said, if I can just do it and get the right answer with a picture, can I do it that way? You know, that's great, but just know that not every problem lends itself well to a picture. You know, so sometimes, I want you to, at very minimum, show this 3-step process. If you want to check it with the picture, awesome. If you want to do the picture first and then see if you get the same answer this way, that's great. But I at least need this process done. Do you understand how to find unit rate using a complex fraction? Because the only thing you need to have done for me are these 3 problems. And look how awesome the problems are there. Circle the 2 words you're talking about. Box out the unit rate that you're looking for. And go from there. Okay? Make sense?